Suppose that we now have two assembly lines that have both been carrying out the procedure of collecting and packaging baseball cards as described in the first lecture. As before, there will be 10 cards in a pack, 10 packs in a box, and 10 boxes in a bag. If both assembly lines have been carrying out the procedure for different amounts of time, it is likely that they will each have collected and packaged a different number of baseball cards. Now suppose we want to join together the unpackaged baseball cards, packs of cards, and boxes of packs on the conveyor belt in the first assembly line with the unpackaged baseball cards, packs of cards, and boxes of packs on the conveyor belt in the second assembly line. We might want to split the assembly line into two and join their collected cards in order to process the baseball card packaging and counting more efficiently. For example, the individual who collects bags has to wait for 1,000 cards to be collected before she collects her first bag. She then has to wait for an additional 1,000 cards to be collected before she collects her next bag. If we move her to the second assembly line to collect individual cards, which continuously roll on the conveyor belt, this would be a much more efficient use of her time, since she would no longer be waiting for extended periods of time between contributions to the workload. Now if we're joining together the baseball cards that have been collected on the two assembly lines, then it makes sense for us to keep track of how many there are in total and represent this. Because the representation that we are using for how many cards we have separates our number of cards into how many boxes, packs, and unpackaged cards we have, we can have the two assembly lines drop their packages to the floor below them and count each pile. If everyone drops what they've collected onto the floor below them, then the pile on the right will contain all unpackaged baseball cards collected on the two assembly lines. The pile to the left of it will contain all packs not in boxes collected on the two assembly lines, and the pile to the left of it will contain all boxes collected on the two assembly lines. Therefore, if we join together all of the piles on the floor, we will have joined together all baseball cards collected on the two assembly lines. However, since some piles can end up having more than 10 objects, some packages of 10 may need to be formed and then passed to the neighboring pile on the left, just like a person on the assembly line does when he or she has collected 10 in order to represent this total. After we know that each pile has no more than 10 objects, we can form a representation of the number of baseball cards dropped on the floor by having a digit represent the number in each pile and joining together the digits of each pile like we did on the assembly line. In other words, we put the digits together in the order of the size of the package in the pile, with the leftmost digit representing the number of objects in the pile with the largest packages, and the rightmost digit representing the number of unpackaged baseball cards. Since the number of packages in a pile can be increased by 1, formed from 10 objects on the right, we deal with the rightmost pile of individual cards first, and proceed left to packs and then boxes when determining how many packages are in each pile. In other words, we start by checking how many unpackaged baseball cards are on the floor and form packs of 10 cards as necessary. We then pass each pack formed to the pile of packs on the left and proceed to check how many packs there are in the pile of packs, forming boxes of 10 packs as necessary. Formed boxes are then passed to the box pile on the left, and we proceed to check to see if we can form bags of 10 boxes. If we can, we pass these bags to the bag pile and continue this process of forming packages of 10 objects, passing them to the neighboring pile on the left, and proceeding to move to the pile to the left until we have traversed all piles and left no pile with more than 9 objects. A concrete example of how this procedure is carried out is shown in the frames currently being displayed. Here we have each column of assembly line workers drop their packages one at a time, starting with the one on the right. An individual then forms all packages of 10 that he can from each pile formed and throws them up over the neighboring pile on the left. As he does this, he leaves behind signs on each of the piles he's passed, representing how many objects are left in them after the packages of 10 have been formed and at most 9 remain. To symbolically show what we're doing with these numbers, we'll need a symbol to represent this operation of joining packages together. So let's use the plus sign. Also, let's separate the digit representations of the packages on the conveyor belts with the digit representations of the packages in the piles with a solid line. Finally, as we carry out the procedure, let's use carry digits above the signs from the top assembly line to represent the number of packages that are thrown up over neighboring piles to the left. Now let's watch this process in action with stick figures and packages being replaced by signs. The formed pack from the 10 baseball cards in the unwrapped baseball card pile and the formed bag from the 10 boxes in the box pile that are thrown up are replaced by signs with ones to represent that one additional package is being added to the neighboring pile on the left in each case. These frames will serve as the transition between the pictures of the process in action as shown before and the pure symbolic representation that will be shown. Now let's show the process in this example without all the stick figures, conveyor belts, baseball cards, and packages, and leave only the signs. When you solve addition problems, you will probably have to work with the symbolic representations of numbers, and therefore you probably won't get to count pictures of objects. You can of course draw objects to count, so for example, if you're adding 7 and 5 like you do here with boxes, you can draw 7 objects and then draw 5 more before counting the total that would be dropped in a pile. However, it would probably be better to count the next 5 numbers after 7 by uttering 8, 9, 10, 11, 12. Better still would be to familiarize yourself with the following addition table. To add 2 numbers, go to the row with the first number, and in that row, go over the column with the second number. The number in that cell is the sum of the 2 numbers. So to add 7 and 5, go to the row with 7, and then move over to the column with 5 to see that you get 12. There are certain facts that will help making knowing this addition table simpler. For example, adding 5 and 7 is the same as adding 7 and 5, since joining 5 together with 7 yields the same total as joining 7 together with 5. The same is true with adding any 2 numbers. So once you know that 4 plus 6 is 10, for example, you know that 6 plus 4 is also 10. Adding with 9 is also simple because it only takes 1 to form a package of 10, so that you can have 1 less than the number more than 10. For example, if you were adding 9 and 5, you could take 1 away from 5 to form the package of 10 and be left with 4, so you know that you have 14 in total, or 1 less than 5 more than 10.